Hey everybody, what are we doing? Actually, let's turn down the gain just a little bit, like 3 decibels, so I'm not blowing anybody out. I decided to try and get going on stream a little early today, so I'm still setting up a whole bunch of stuff. So, excuse me while I shill myself in places where I typically shill myself. Actually, let's just go to the chatting screen. And oh, where are my links? Where are my links? Oh God. Oh man, where else do I need to do the thing, do the needful? But yeah, let's see, what was I? Sully, yeah, the Raspberry Pi Pico isn't a Raspberry Pi as you and I would usually know it. It's not a Linux machine. It's not running Raspbian. It's not running an operating system. It is an Arduino. It's a beefed up Arduino because it's running an ARM Cortex M0 Plus. Don't quote me on that. So if I go into dev, I make the directory. Actually, I think I already have a Pico directory in my dev folder. I do. All right, that is good. Actually, let me. Ooh, what is this song? I know you probably know. Camouflaged Underneath. This is already kind of turning out a little kind of smooth. Let me turn this up for you guys. We go ahead and also plug in the device. So Launch tmux. Streaming profile. Raspberry Pi pinout. Or not, Pico. If I pull that up, it just show me the diagram. I don't need a web page. Awesome. So I've got that. Yeah, so today might be a little scuffed because I actually only got this like yesterday and I haven't even really had a chance to experiment with it other than like I got a Blinky project running and I got, what else was it that I got running? I did manage to get a virtual COM port so that I can read data from it in the Minicom terminal. So if you will hold, I think we can studio mode just so I can pull this up. That's running good. What is on Randwin? Go pin out. Good. So yeah, I'll go ahead and go to the out of studio mode and let's go ahead and pull this up. So I've already got a whole bunch of examples pulled up of code. So today is gonna be a lot of C and a lot of just reading, honestly. So if I, not YouTube, what am I looking for? So there's the pinout. Let's go into the I2C and see what we have. We have all kinds of different projects. MCP 9808, what's that? Pico SDK import CMake file, but I can only find the wiki. Do you have a page for that? Because I'm probably not using the same thing as you are. High accuracy I2C temperature sensor. Okay. So there might actually be, what is this module I have? Not that. I don't have an LCD. EA 101 1010D, no. 11. Oh, what is it that I bought? Hang on, I have to look at it physically. ADS 1115 is the name of the chip. ADS 1115 Raspberry Pi Pico. See if there's any like. Let's turn that off. Necessary cookies only. Okay, found this. ADS. MicroPython driver from scratch part 2. Oh, it's a Python? I was hoping to do C. Double joy. Oh, no. NRF. Widen this out a little bit. Actually. So we have joystick. There's that. Yeah, Sully, if you have the wiki page, I can pull up the wiki page and look at the same thing that you're looking at. Because we're probably not looking at the same thing. Let's see, documentation. Pico SDK. Let me copy that. Let's see what it says. Documentation, getting started with the Raspberry Pi Pico, connecting the internet to the Pico W. Sully, are you on Windows or Linux? They're cloning the SDK locally. I'm gonna assume Debian right now. Okay. So copy import.cmake from the SDK into your project directory. Okay. Set up your project to point to use the Raspberry Pi Pico SDK, either by cloning the SDK locally. Well, let's just go look for the file. Pico SDK import.cmake. Where is the search? You're not about to tell me I need to log in to search, are you? Docs CMake. Platform? Pico.cmake. Post RP2040. Pico.cmake. Reload? No. Alright, well, what if I just go ahead and clone this then? Code, let's clone it. Instead of in Pico examples, Pico git clone that. And just leave it as it. Pico SDK. Oh man, what's the find Linux find file in folder? I'm still bad at this, so how to find a file from the command line. What's the name? Okay. Find name Pico SDK import.cmake. Says it's an external, so Pico SDK import.cmake. This can be dropped into an external project to help locate this SDK. It should be included prior to the project. Pico SDK path. Oh, what was the? Because I'm on Arch. Arch. No, hang on. Pico SDK AUR. I think I installed this one. Actually, Paru S Pico SDK. Okay, yeah, I installed Raspberry Pi Pico SDK Git. Let me just mess around with my windows so that they match up a little better. So the package build that, and then it says I have to source something, source some file. PicoSDK.sh. Export P. Okay, yeah. So there's that. Let's close that out. Do that. Actually, font could afford. We can afford the font to be a little bigger on here, right? Okay. So if we Pico examples. Now let's go in and look at the some of the I2C projects. Because the chip I have, bus scan? What's bus scan? All right. So there's our imports. Ooh, that's a nice song, but let's turn that down just a touch. I2C reserves some addresses for special purposes. We exclude those from the scan. Actually, let's see. 0123. One byte dummy read from the probe address. Go examples. I think what actually, you know what? Instead of I2C, I'll worry about that later. Let's look at the actual ADC. Ooh, ADC console? Let's see what ADC console does. Okay, so we print commands, sample once, sample many, wiggle the pins. Okay, so on this one, we init all the standard I/O. We init the ADC. Set temperature sensor enabled. Okay. And for that, we set all bits to 0. We disable polls. 2040 ADC testing console. Print help. Alright. I'm going to... what you may see in the thumbnail. I should probably just put the image. In fact, let me do that. I grab the image from my Discord, which, by the way, discord.amperature.com. Welcome if you would like to join in the community, where I'm trying to build a community of people who can do things and build shit and just generally create things. So I have that. Let's go back here. I will add not a scene. I want image, not a slideshow, just an image. Image, Discord, Pi stuff. Oh no. I will disable that so that I can actually do it this way. Instant camera 24. Oh, can I not? Alright, so let me then... I feel like such an amateur. Save image to documents. Actually, no, stream assets. Buy stuff. And then stream assets, Pi stuff.jpg. Boom. Okay. Jesus Christ. It's like I'm only pretending to be. Oh, that is a huge image. All right. This is currently what my setup on my desk looks like. You may notice nothing's actually connected because I didn't want to. Does the Pico? No, it's not. It's bare metal. Nothing. It's not a Linux board. It's a microcontroller. If you've ever used, if you've used Arduino, that's what you should be more familiar with. It is not a single board computer. It is not a full computer unto itself. It is just a microcontroller. So everything you run on it, you compile a program to run on bare metal. I think there's no chip that's actually memory. I'm pretty sure they only have the one SKU for the RP2040. Yeah. But yeah, that's the core of all of it is what if you look at the big red board up at the top left of that breadboard image, you may have ideas of where I'm going with this. So I'm gonna go look at the pinout and look and see if I can find. So there's VBus, VSys, ground. So I don't have a camera set up for this, so I need to make jumpers for all of these things that I'm doing. So where is... Nice. Okay, so just zoom in a little bit more. It doesn't like this. It's not like what I'm doing. Do I solder? In fact, the image I haven't really done any like flat. I've forgotten what the term is. I can do through-hole soldering pretty good. I haven't really done any extensive soldering of surface mount. Surface mount. That's what I'm thinking of. I haven't done any surface mount soldering. I'm seeing ever since I got out of electronics, but I put electronics on the back burner. The big idea was soldering surface mount should really be done either in a reflow or on a hot plate or using hot air. And now I see everybody's just like, no, just do it with an iron. Just do it with an iron. So maybe one of these days, if I actually get a camera that can do like hand cam stuff, or like a rig so that my camera points down at the desk, I might do some soldering stuff. Once I have a board in hand, I might do that. So, okay, ADCV reference, ADC2. Okay, so pins 31. I'm gonna do pin 31. So if we start from the top right, that's 40, and we count down to 31. Okay. So V bus, 3v3 out. So if I'm gonna snip a wire here. And it is stripped. Beat bus. I've forgotten what the this is how bad it's gotten for me. How long it's been. I've forgotten the difference between V-bus and V-sys. I can probably just look it up. Difference between V-bus and V-sys. In Pico? Shit. Raspberry Pico datasheet. V-bus. Pin 40. Okay, that's the pin out. Aha. Good lord, I can't... Actually, hang on. Where's the... Just a second. I'm going to hide the browser window as I mess around with some settings inside of this browser profile. What am I looking for? Smooth scrolling? Use auto scrolling. Okay. Now, okay, much better. Okay. Close that tab. So, V-bus is the micro USB input voltage. Connected to micro USB port pin 1 is normally 5 volt. V-sys is the main system input voltage, which can vary in the allowed range from 1.8 to 5.5. And is used by the onboard SMPS to generate 3 volts. 3v3EN connects to the onboard SMPS enable pin and is pulled high via a 100k ohm resistor. Disable 3.3 volts, short this pin low. 3v3 is the main 3 volt power supply to the RP2040 and its IO, and is generated by the onboard switching power supplies. I forget what the M is. Switching mode power supply. This pin can be used to power external circuitry. Maximum output current will depend on load and V-sys. It is recommended to keep the load on this pin under 300 milliamps. Got it. Okay, so let's use 3.3 volts as our... Actually, what's the ADC? ADC mode. Measure V-sys. Oh, what? Okay, a few GPIO pins are used for internal board functions. 29. SPI and clock mode. ADC to measure. Okay, no. 12-bit, 500,000 SPS analog. 500,000 samples per second. Digital peripherals. What's the, like, limit on the ADC? W, ADC capable. Using the ADC, what page am I? Oh, shit. 3.3. Page 11. Okay. Okay. Surface mount footprint. 9. So it's not actually page 11. It's just page 11 according to the book. General purpose I/O. Here we go. The 2040 ADC does not have an on-chip reference. It uses its own power supply as a reference. On the Pico W, it is generated from the switch mode power supply by using an RC filter. Some PSU noise will not be filtered. The ADC draws current if the temperature sense diode is disabled, which can vary between chips. There will be an inherent offset, about 150 microamps, roughly 30 millivolts. There's a small difference in current draw when the ADC is sampling. Changing the resistance between VREF and the 3.3 volt pin can reduce the offset at the expense of more noise. Driving the SMPS mode pin high forces the power supply into PWM mode. Okay. So we shunt the reference draw. The shunt reference will draw continuous current through the 200 ohm filter resistor. Okay. Let me see if there's a Pico ADC example circuit. Let me see what some people do. See if I can find example stuff. AD conversion, polling interrupt, ADC revolution. Okay, there's a potentiometer. Oh, okay. So they just literally just bang, bang, bang. No other circuitry required. That's actually really nice. So I'm gonna go ahead and do some wiring. My voice is gonna be sounding weird for a few seconds while I lean forward. All right, and I'm gonna go ahead and make a ground reference wire. So Sully, did you actually end up making, like, doing anything more with that Arduino project you were mentioning? As I search for things to talk about while I strip this wire. There we go. Man, it should be a visual medium. I really should have a camera, but I was too excited to actually start on this project before I was able to start setting up a camera rig. There is not really. Arduino kind of sucks because it doesn't like being used outside of the official IDE, and the Due doesn't have good support for C++. Ah, I see. Yeah, that's always been. If you knew me from years and years ago, not that long ago, but years ago, when I was more active streaming electronic stuff, I would complain often about anyone who came to me saying, well, why don't you use Arduino for stuff? I'd say, oh, what do you mean with Arduino? Do you mean the IDE? Do you mean any specific piece of hardware? And I'm not, God in heaven, I'm not using that IDE. Jesus Christ, that thing is horrible. But yeah, it's not a particularly well executed brand, I should say. Like they make all kinds of weird branding decisions. Okay. Oh, I should make that jumper much longer. Or instead of making the jumper longer, I'll just put the yeah, it really is meant for kids in classrooms. And there's nothing necessarily wrong with that, but there was definitely a perception like people just started using it for more robust things, and it works, but the chip inside the Arduino, in every Arduino, is capable of so much more, and you don't get access to those things because of the bootloader and because of the libraries and because of the decisions that they had to make in order to make the Arduino good for kids in classrooms. That said, but with all that said, it's still good for kids in classrooms, but like without going into, hang on just a second, I gotta wire this up. Oh, that wire's not long enough. Hang on. But it'll, even though it's good for kids in classrooms, it'll do like rudimentary things if all you really need is rudimentary things done. Which for a lot of people, they kind of really only needed rudimentary things. Like even the circuit you see is kind of an Arduino thing. Like all it is like, here's how to wire up a potentiometer. Even though I feel like I should know these things, it's good to have stuff to review. All right, that's so GP28. All right, now I need one more power so that I can have power to the potentiometer, and then one for ground. Yeah, about that long. And I'll be posting I'll be updating the picture that you see there with more. Yeah, there we go. So that will go onto the next one over. And then let's make a ground. Oh, nope. About that long. Let's cut and strip. Pull. And pull. Almost got it. Oh, I should move it over another spot. There we go. All right. Now, if you don't mind, I'm gonna go ahead and take another picture to show you what my wiring looks like right now, because that's the best I can do. There's no video feed. And I really should. I'm gonna put, so you don't have to see that happen. Save image, stream assets, apply stuff to a JPEG. There we go. So then grab that. So this is what we're looking at now. This is what I'm looking at now. Okay, hang on. What did you say in chat, Sully? Pico's C++ SDK seems to work seriously good, except I have one gripe with it. It doesn't seem to work with playing D. I do want to mention, it's not C++, it is C. C++ is not quite what we're working with. It is raw ass C as far as I'm aware. And yeah, as far as I know, I think, especially when you're working with hardware, you're kind of, I don't know if I want to call it vendor lock-in, but because you're not targeting the x86 and you're not targeting the x86 and you're not targeting like an ARM platform, you're targeting very specific architectures. And when you have to compile, there's a lot of extra work that goes into the compilation, like the build system, right? But the build system, oh, okay, it's both. Like you run into requirements like that. Hang on for just a second. I'm gonna go grab something on my other desk. Yeah, unfortunately, the problem you're having, I don't know that I'm gonna be all that well equipped to help you with. It has been a while since I actually worked in C, and I actually worked in compiling for electronics. So we'll see what happens. Now, let's actually get into some programming. I think what I'm gonna do is just compile the example. So if I go out of here, can I just do a make? J4. There's no make files. Oh no. Let's see. Oh, that's right, because it's in build ADC console. And then we do make J4. That's right. Okay, and there's the file UF2. And so if I unplug the Pi Pico, I hold boot select. Here's my favorite part about the Pi Pico that I've learned. Here's how you actually deploy to it. And this may be a bootloader thing. What you do is you unplug it, you depower it, you hold the button. If you see there on the button that's up near the USB plug, called boot select, you hold that, plug it back in, and it goes into a boot select mode. So if I do ls block, you'll see SDA1 run media amp RP2. So it's actually instantiated as a flash drive. So now what I do is I copy. Wait, who owns it? Hang on. Run media amp. I own it. Okay. So I just copy ADC console UF2 to run media amp. Boom. Copy the file over. Let's do mini. Let's see. I think it's dev tty. So we have an ACM0. Is it ACM0? Let's see. Minicom dev tty ACM0. Permission denied. Resyncing. Sample rate requested. Oh, it doesn't like that. May 3rd. Oh, compiled on May 3rd. Compile commands thing to work, but it doesn't see anything it's supposed to. Interesting. So, yes, okay, minicom, let's see. Really, it's not, let's see, instead of build, go back to ADC, AC console. No? Actually, yeah. So, ADC console, vim, console.c. Let's see what's happening here. Actually, target link libraries. Okay, so why is it add URL via Pico set program URL? Real interesting. Okay, so we're init all, ADC init. So we're doing printf, but where does printf get sent? I guess, does printf... Actually, let me... Oh, nope. I remember the big one that I was using before. Hello, ADC. There's GPIO, ADC example. So it's printfing. Is it not? So nope. There's ACM0. Instead of that, what was the one I was using? Was it UART? Hello, UART. Okay, so we have create a map, Pico enable. So we enable standard IO USB, so UART1. Enable standard IO UART So we turn off UART, turn on USB. So let me actually just copy that. Oh, I'm just about added the whole program, or that whole CMake list file into Twitch chat. So Pico examples, ADC, console, CMake. So let's grab Pico enable standard IO, and we'll say ADC console. Target link libraries, standard lib. Do that. Actually, it's probably best cd uart. Hello uart. We vim into that. Grab these. What does this look like? Okay, that's turning the light on and off. Printf. So we just... let's compare it to what we see at the ADC console. There's print help. Init all, ADC init, ADC set temperature sensor enabled. So we switch to switching channel, starting capture. Version factor 3.3. That seems... let's compare the CMake lists actually. Okay, so we target link libraries, Pico standard lib, hardware ADC in the actual project. Add extra outputs. Similar. Maybe, do I need to control... standard IO, Pico, enable, standard IO UART, ADC console 0. So now it looks like it's the same CMake lists. Do I then need to redo the build? So if I go back, build, CMake, remake, we're rebuilding all of the CMake files. Got it. Then ADC, hello ADC, actually ADC console. Right? So then we have all that. We'll make J4, which should compile all of this. Awesome. So then I can unplug the Pi. There it is. Hold the boot select button. Plug it back in. Then I can CP ADC console UF2 to run media and 2. That should cause it to reboot. Yes. So then we have, there's the Pico. So would that mean, aha, there's ACM1 minicom dev tty ACM1. Permission denied. Give it, go in as sudo h sample once. So if I turn, so it's roughly about 5.7. If I turn this all the way up, oh, it's floating. Select a channel C1, switch to channel 1. What channel is this? Why is the music? What happened to my music? Spotify cannot play this right now. Why? Why? What is happening? Has it just decided to say no? Try it again. Okay, it's playing on my end, and it is playing through OBS. Fucking Spotify. I don't know what's up with Spotify. All right, so channel 1, let's sample once. It's not really working. Okay, so C2. Really? C3? Wiggle pins. Wiggling halted. No, that's still about 1.5. That is really awkward. So C1. Seems to be having no effect. Let me get my multimeter out, see what my multimeter says. All right, I have returned with my multimeter. So there's DC. So yeah. So is there? There's the O. So that. Okay, so my multimeter is saying between the power rail and the ground rail is about 3.25. Now my multimeter says there should be about... Really? Hang on, I may have to pull this out. So, DTB... That is really interesting. Let me see if there's a thing on Amazon or something. Let me get rid of my browser window because I don't need you guys seeing if anything pops up on Amazon when I'm not logged in. Slide pot. So, yeah, I'll bring the thing back up. I let go, slide pot 10K. Customer reviews, images. Is there like a diagram they have? Diagram. Okay, that's the basic diagram. What about this thing? Output A, output B, VCC and ground. If I do it like this. Actually, let me voltage. Let me make sure the voltage is actually reaching. Okay, yes, according to my multimeter, 3.25 is reaching actual thing. 1.45 should be the readout. If I slide it over a little bit. 3 okay. So then, let's go back to our channel 0, I think. Sample. Doesn't really seem like the voltage is going up much at all. Okay, so C1. Really low voltage. And there doesn't seem to be any effect as I mess around with 2. Oh. So channel 2, it's channel 2, and it's working correctly. Look at that. Okay. So, I actually officially have a working read on a working slide pot. Any of you who are looking at the picture may recognize what that slide pot looks like. What picture? Do I still have the picture of my circuit up? Any of you looking at this may recognize what that slide pot circuit looks like, and that may lead you to wonder, what am I doing with it? If it looks familiar at all to you, you may notice. Let me see if I have. Can I... start to wonder what... Oh, sorry. You start to wonder what I could be building, couldn't you? So I think the big reveal right now is to just go ahead and mention Deej. So, an open source hardware volume mixer for Windows and Linux PCs. So, I've been fascinated by projects that mostly can work on stream. It's been something that I have for years. I've always liked the idea of being able to control the volumes individually, especially now. Let me move the circuit. Piece of being able to just use fader positions to control the audio production on stream. I think with Deej, it's missing a couple of things that I'd really like. He's built it using specifically an Arduino. So he has slide pots, he has all of those, and he has, what is that, 5 faders? And he's actually controlling the native, like the Windows and the Linux system volumes for these programs. I want to see if I can build it to where I'm directly controlling OBS. I think that's the way this project ideally will go. And I realized I had chat scrolled way the hell up. I basically wasn't reading chat for the longest time. So the one thing I want to do now is I want to see if I can build the hardware component. The hardware component, he says, does he have the, where is the hardware schematic software? The code running on the C is a C program. Deej 5 sliders vanilla. Ah. Okay. That is an... Oh, that's an INO. Okay. So... Update slider values. No. Jesus. Send the slider values with build string. And then we write... So he writes a numerical value, number of sliders, 1. Okay. I think that's enough to start, at least enough that I can find myself. I'm gonna tell you what I'm gonna do. I'm gonna take a little break. And I will be right back. I gotta get up, stretch my legs a little bit, since we're kind of at the quote-unquote hardware is built, prototyped level. It's good that we're there, but just need to reset my brain a little bit, get up, kick my legs out, walk around. Also need to take a little bit of a workout break, and I will be right back. I have returned. And I'm ready to, let's see. Put this up here. Remind y'all what I'm working with. To get rid of BRB, and I think time to start looking at the actual ADC code. And see what it is doing. So let's start closing folds. Oh, nope. There we go. So we have all our core functions. We have main, actually. We have main, we have not in flash function. Music's putting you in the mood. Oh, I actually probably should turn the music a little bit down since I'm back from my break. What are you doing? What are you up to, Haney? What do you got going on? How's your power supply doing? I see on your Discord that you were having some issues, and I see that like it's caused you to not be able to stream for past couple days. Hope you're not expecting me to take over the morning shift. Jesus Christ. You don't pay me enough for that shit. Oh, it's a whole... You're gonna have to buy a new PC? Do you do pre-builts, or do you buy parts and assemble? Because I'm starting to think maybe I want to do a new build for a new PC build myself. Even though it's like I have a reasonably powerful beast, but now that I'm streaming again, it's like, oh, my GPU is the first generation stream PC. I go with micro pre-builts that are tiny. Ah, okay, I see what you're saying. So like a NUC or something, and then maybe you put like a capture card inside of the NUC, and it doesn't have to be like a actual branded NUC, but you know what I'm talking about. So we're using the ADC. Capture card that runs into it. What capture card are you using, if you don't mind me asking? Because I'm also like, now that I'm in the what are we building tonight? Well, I'll show you what the circuit looks like right now. You may see that well, let's see if what I was Googling mere moments ago did not make it obvious. If what I was Googling mere moments ago before you arrived did not make it obvious what I've been trying to build, or what my intent on building is. Let me see if I can find, where is the GitHub repo for Deej? Yeah, here we go. So Deej is basically open source hardware volume mixer for Windows and Linux. There is one thing about Deej that I kind of would like to rectify. I think I'd like to use a hardware volume mixer that controls OBS directly rather than going through the system volume, because I am a Linux streamer and therefore I get access to Pipewire, where in software I can control volume that goes to my ears versus volume that goes to OBS. So I control OBS volume and my own personal volume completely separately, which means this would come in very handy Something like this would come in very handy for streaming, and I want to control specifically the stream. So, and you can see he even lays out in the image. There's a fader that goes, I'm guessing this is for master volume, for Chrome, for his music, whatever game he's playing, for even Discord, and then his mic. So, in theory, I could just use all of this and keep it run, or use it like this as it is. The unfortunate part is he controls the actual system volumes. I want to control OBS. So eventually, I think what I'm gonna do is either request. Let me see if he has. What's his issues? Standardized configs for storing. What about OBS? WebSocket? Okay, so he doesn't have any open issues related to OBS WebSocket. When invert sliders is true, unnecessary toast notification. It controls master when using Bluetooth. If run from a different folder, config is not found despite being in the same directory as the executable. Deej does not reconnect after USB gets unplugged and plugged in again. Ooh. Nice addition to make the Deej hot swappable. I intend to do connection stability pass. Okay. What I want to do in the future is either I need to decide if I'm going to actually try and put in a pull request to Deej or just make a new thing entirely. So what Deej does, and I'll move my code out of the way, is he's using he has a diagram. Is he's using an Arduino. And the Arduino has a bunch of slide pots, and they go in and they get read by the ADC. The ADC then reads that through a virtual COM port into his computer or his stream PC, which he then controls using the faders, all that. The first thing I want to do is I don't want to use Arduino as the hardware, so I'm going to be building the hardware based on the Raspberry Pi Pico. If you know what the Raspberry Pi Pico is, it is a ARM Cortex M0? Let me check. Raspberry Pi Pico architecture. Datasheet. DRP 2040. About the Pico. Microcontroller with 2 megabytes of flash. Design files, mechanical specification. Power minimal yet flexible. No, there's nothing here that says there's 2 UARTs, 2 I2Cs, 2 SPIs, and 16 pulse width modulation. I mean, electrical engineering is what my education is in. It is to my great shame I never actually ended up employed in this. But this is this is what I went to school for. So 2 megabytes of flash, that means there's ads. Hang on for a second. So while people have ads, I'm gonna need to put up like some kind of system to where I can detect when ads are happening. I think. But once no Prime option for sub. I mean, I am still technically an affiliate, I think. You're not a sub? In fact, I think I'm unless the fact that I didn't stream for several years changed that. But you should be, like, Hanny, unless you, if I would appreciate a sub. Like, I don't need it. I'm doing well enough in my career that, and I'm making enough money that I don't really need to rely on, I can sub, but it won't let me use Prime, and I haven't used it. Oh, maybe, is Prime now a partner thing? That's interesting. But yeah, there we go. Oh, oh, Jesus Christ, we're back. Okay, so, oh, there we go. And Haney with the Prime sub now upgrades to a D tier subscriber. Those of you who remember those of you who are players of Devil May Cry understand that he has executed a D level combo. But anyway, this is like it is to my great. Oh, here we go. Yeah, dual core Cortex M0 up to 133 megahertz. Yeah, this is what my education is in. Unfortunately, it's to my great shame, I never got a job in it. I think I want to try and go back and see if I can do this again. Building out hardware, doing electronics. Took a lot of classes, spent a lot of money. Let's see, RP2040. So it has 2 megabytes of flash, which means your programs, when compiled, can only take up to 2 megabytes of space. Although, well, when compiled and when you account for the actual memory that the program needs to use beyond the actual program itself, you only have 2 megabytes. Micro USB port for power and data. DIP style, dual inline package, 1 millimeter thick PCB. So that's DIP means dual inline means here's your one inline, here's your second inline, and it fits onto a breadboard. If you can see, all of the electronics are fitting onto a breadboard if you ever used one of those. 23G general purpose input output are digital only, and 3 are ADC capable. So that's going to be something that we need to rectify in the future somehow. I think we can extend it. In fact, if you're looking very carefully at the blue part of the picture, I think that's exactly how we're going to extend it. Maybe not that chip in particular, since it only has 3 of them. But who knows? So we have dual Cortex M0 plus 33 megahertz. Now, what was I looking up before? What was it that I was trying to look up? Oh yeah, I was trying to look up. I want to convert from the Arduino, which he's using an Uno, which is in an AT Mega architecture. I want to use the ARM Cortex M0. So I'm gonna see if I can make a Deej compatible board. Or do I? Okay, so I've got some options in front of me. Let me just. I've got options in front of me. So I have. Let me move the picture. 3 options. Use Deej. Pull request for OBS WebSockets. Fork. Remake Deej like for OBS control. Or the third option, you make MIDI controller for OBS MIDI plugin. So that is another option available to me, is I could turn this into a MIDI device and set up like 8 faders and set those 8 and install the MIDI plugin for OBS. Because so many people that I'm aware of, let me look, Amazon. MIDI? Yeah, let's see. What is the... Akai. Is it Akai? MPC, let's see. Control, is it? Akai MIDI controller. Okay, yeah, MIDI mix. So, what I have seen some people do, and that's on Amazon. Where is it? You only know that for music jams? And that's what they're mostly used for audio production. But guess what you are as a streamer? You also produce your audio. Oh shit. That picture is gonna bother the shit out of me. Every time I want someone to look over there, I have to look over there because I'm blocking the page. It's a nightmare. So, MPK Mini. Products, MPC. Keyboards? Controllers. So, I became aware. So, there's the APC Mini. What I've learned is that there are a few Linux streamers who use something like this to basically, like they basically turned this into a stream deck with volume controls, or more accurately, they turned this into a stream deck plus a Go XLR all in one. And in my head, I'm like, why buy it when I could build it? Why buy it for $100 when I could pay triple and build my own, right? So, well, not only that, I could buy it, I could pay triple, build my own, and then I could build a whole bunch more and possibly sell them. You know, that's an option available to me. Make my own money. Because I've seen a whole bunch of people building their own Deej boards. Where is... Okay, no, that's the Pico SDK. Get rid of that. Don't need that, don't need that. That'll probably stay useful for a little bit. Don't need Pico. Where is... There's the pinout. So... We're using... if you look on the diagram... I'll just zoom in. If you look on the diagram, there's pin 38 there. The ground, then there's 3 volts out on pin 36. And then GP28 is on pin 34, which is also a analog to digital conversion channel 2. So if you can believe me, so let's see, is it quit? Okay, so here's the sample code that I've been running on the device now. So if I do, is it sample many? And it just keeps going? Okay, no, that's not how it works. So the sample code I'm running is actually feeding a console to my PC through the virtual COM port. So if I wiggle, I don't know what wiggling pins means. So if I sample once, the board tells me through the virtual COM port that channel 2 is at 2.2 volts. And if I move the slider a little bit to the left, it's saying 8 volts. So if I keep hitting sample once, it's staying at about 0.8. Now I'm going to slowly move it to the right. And it creates, and it gives it more and more voltage. I need to move this out of the way until I reach about 2.9. So what is our limit? What is our lower limit? Oh, how low can we go on this device here? I have to fold some wires down because they're not Okay, so now it's all the way over to the left. Okay, so we have FFF. Let's see. That is 0, 1, 2. There's 9. There's A, B, C, D, E, F, so that's 15. Actually, what is the schematic? Where's the data sheet at? Okay, ADC. 4 can be used for ADC. ADC compatible. Multifunction. 12-bit. 12-bit data, 500 kilosamples per second. ADC. So, one thing I don't want to do immediately is commit to using just the ADC on board. But you know what? Hey, why not? Just as a prototype phase. The blue chip that you see there, what's the ADS 1115 actually. ADS 1115, made by Texas Instruments. So it's 16-bit, 860 samples per second. Really? It's only 4 channels, so we would only be able to make 4 faders. PGA. So, what was it? The MCP 3208, I think it was. Is that it? There we go. 12-bit, 100,000 samples per second, 8-channel analog to digital converter. I think eventually I will use an MCP 3208 for the for what I end up building. So we can plug in 8 faders or 8 potentiometers and control 8 different channels. Now, you probably don't actually need more than... So if I'm looking at the diagram from... Where is the Deej? Deej. Come on, there we go. Actually, let's go to... He's got a website that just redirects here. Got it. He's got 1, 2, 3, 4, 5, 6. He's got 6 faders. As of right now, the Pico can only do 4, I think. We have 1, 0, 2. Oh, it can only do 3. That's right. So if I change to 3, switch to channel 3, 4, 5. Can I sample those? Okay, so that's floating, and it's just gonna keep floating. Switch to channel 2. Sample that. Or wait, which channel am I on? 0, sample. That's floating, so it's gonna be switch around. C1, channel 1. That's gonna float. C2. And that is a little bit more controlled, right? And this is me messing with the potentiometer. So the blue chip that you see on, or the blue little board, that's an ADS 1115. And it communicates to the Pico using a protocol called I2C. I forget what that stands for. But I2C. Inter-integrated circuit. Alternatively known as I2C, IIC, synchronous multi-controller, So, I'm less experienced with I2C. Oh yeah, there's all kinds of... Once you get into actually building hardware, the different communication protocols from chip to chip is really fascinating. Because you and I, we probably know HDMI, we probably know USB, but do you know what UART is? Do you know what SPI is. Actually, what's SPI stand for again? Serial Peripheral Interface. I actually really liked SPI when I was in my what's the, you got a question, Annie? So there's SPI. You want to know how SPI works? You're clueless. So UART was one of my favorites, and UART is probably actually what's being sent over here with the printfs. But the thing you got to keep in mind is that when one tiny piece of silicon wants to talk to another tiny piece of silicon, we gotta have a language specified, right? We gotta make sure that they can talk to each other. So you have different protocols. My personal favorite is, let's see. My personal favorite is SPI. The chip you see on the blue chip you see on the board there is through I2C. So how SPI works, you see the S clock. If you see on the orange square over there, maybe I should just hang on. Where's the? What if I said I wanted to capture the cursor? Oh boy. Oh boy. What's the 300 pick? There we go. So now that I have a cursor on the screen, we have signals called S clock, MOSI, MISO, and then so in this diagram here, SPI is laid out as we have a master controller and 3 slaves. Over here on the master, we have a clock, which basically says, well, the MOSI, if you see the arrow, there's the MOSI signal that goes to that, and one of them goes to every slave. And the MOSI is actually the way, it's called master out, slave in, and which means the communication comes from the SPI master and it goes into every SPI slave. And that is how the master talks to the slave. And then there's another one, which is master in, slave out, which is how the slaves talk to the master chip. And S clock is, how do I explain it? It's basically the signal that says, don't you mean main and branches? They're not quite, because I guess you could say client and server. I don't know. I think main and branches is probably not applicable here. Like, it wouldn't actually make sense. But if you wanna talk in those terms, probably client and server would be. So there's the SPI server, and then there's 3 SPI clients. But it's honestly, master slave is probably the best way to think about it, because the master not only controls, it literally controls who can talk. Like you see there, you see SS1, SS2, and SS3. Those are signals that say, okay, only SS1, SPI slave 1 can talk right now. So we'll use client and server for now. So the server says, hey, client 1 is the only one that can talk to me right now. If anyone else tries to talk to me, I get confused, because client or server out, client in, or no, client in, server out. No. The client's talking to the server. Sorry. The clients talking to the server are set up in such a way that they're all using the same line, if you notice. So MISO goes here, it also goes here, and it also goes here. Which means they're technically using the same wire. And yes, these connections are literally just singular wires. Or traces of copper on a PCB, but whatever. But it's using the same copper, which means the voltage has to get pulled high. But who's talking? Well, that's also controlled by the SPI master through slave select pins. The SPI master will pull slave select 1 high and say only slave 1 gets to talk right now if he has something to say to me. Or he'll pull slave 2 high and say, slave 2, do you have anything to say to me? He'll also, the master will also pull the select pin high and then output a command on this wire. So when I pull select 1 high and I say something on Mosi, only slave 1 receives that command. So the control is, the downside of SPY is you need so many different select pins. Like if I have 18 different SPY slaves, you need a new pin, another wire for every single device. Now but I never had a situation where I went beyond like 2 or 3 different devices. So let's do the I2C diagram. So the I2C diagram is you can have as many devices on it as you want. Actually, here we go. So there's data and then there's clock. And you can actually even have more than one master as well. So what the master will do is the master will, instead of using a select pin, he'll actually put out an address. So every one of these slave chips will have an address associated, and your first packet, your first package of data is the address. Here's who I'm talking to right now, and I'm either going to say send me data or I'm about to send you data. Actually, this is probably, yeah, here we go. So the advantage with I2C is you only ever need two data pins. The problem well, there's less of a problem, I guess, because you need to pull it high. Maybe it has more current draw. And, you know, there could also be address bumpage. Like you need to actually do the part in software where you assign everything an address. But sometimes the actual chips themselves will just say, hey, I am this address. I don't care what you tell me. So you need to encode the address of that chip into the software. Then there's UART, which is really just, I think UART, you can do this with any language, or are there specifics that are better for it? So it's not really language. There's not really any different languages, because most of the time it's every language is going to have a driver. The ones that do have a driver, I mean, like the ones that can control microcontrollers are going to have drivers to control ADC, to control all of these things. Because if you look up, I'm using C right now. Oh, jeez, got a picture again. Yeah, picture. So if you look here, I'm using C in this example code, and this is, I can't really tell if it's hard to tell if this is your eyes are what's wrong with your eyes? What happened? Did we break something? I have seen the light. Okay, so yeah, the incredibly short version is there's going to be drivers. So the example tell me we did not break the music again. Or is it just we're waiting for the next track? We're just waiting for the next track. Never mind. All right, I'm gonna move this below. I'm gonna move this below now, playing, so that we actually see the music. Faded Jeans by Harris Heller. In C, well, okay, C is probably gonna be the most popular language still, if you go watch the if you go watch the channel Low Level Learning, he's a big advocate of moving away from C. There's 3 primary languages right now that are going to be used in embedded systems. In anything professional is going to be in C. MicroPython was gaining a lot of ground for a while, and Rust is also gaining some ground. I kind of want to build my project in Rust a little bit, but that's going to take a little bit more learning. So I'm going to, for now, take the strategy of build it first. What is it? Build it fast. No, build it first, then build it right. What is the... Build it faster, build it well. There's a saying. I guess you could say you build it fast first, then you build it right, then you build it to be fast rather than fast. Build it fastly, then build it right, then build it to be fast. Is the is something akin to the saying I remember hearing. So, I guess for now, I'm just gonna study this code for a little bit. So we have standard I/O init all, ADC init, ADC set temperature sensor enable. That's weird. ADC set temperature sensor Pico. Read the internal temperature sensor. Oh, there already is one? According to the data sheet, when it's 27 degrees Celsius, let me zoom in a little bit. Voltage is around 0.7, and for every degree temperature change. So, Pico, special diode connected to ADC4. Really? Is that channel 4? So where is... Which one is the ADC sensor? Let me see, can I get out of this? So we have joystick, microphone, onboard temperature. Ooh, onboard temperature. Let's see what that says. So let's define units as F. Why not? So references for implementation, read onboard temperature. Let's also actually, hang on. What does the CMake list say? Okay, we turn off UART, turn on, wait. And let's actually disable UART and enable the USB. There we go. So references for this implementation, hardware ADC, Pico examples. Where is the documentation on that? Raspberry Pi Pico C SDK PDF. C or C++ SDK. Here we go. Section 411. Hardware ADC. Oh, Jesus. So we have ADC init there. High impedance, no pull-ups. GPIO init 26. Select input. Okay, so we have that, but let's try. Does it say where the temperature sensor is? Pi Pico temperature sensor. Where actually is it? It is probably that black chip right there, right next to the actual RP2040. Let me see if I can get a better look at it. Oh yeah, there's definitely some markings on that. What does that say? I can't read it. Oh, wait, hang on. Image, new tab. Ah. You know, I still can't tell. I'm gonna assume that it is this chip right here on the board. So, let's see. So we have our main, we have our init. Is it doing printfs? It is doing printfs, okay. So let's first go back. Let's go back into our build. CMake ... Configuring, okay, awesome. ADC, onboard temperature. We then make J4. That's compiling. We have our UF2. So now what I'm going to do is I'm going to unplug this and then plug it back in bootloader mode. I will copy onboard temperature UF2 to run media, and that's going to deploy the file. And if I do sudo, onboard temperature is 61.47 degrees Fahrenheit, apparently. Oh. Okay, so now that I'm putting my finger directly onto chip, it does seem to be raising the temperature of the chip, right? I mean, it's only 60. It's not this. It's barely any movement at all. No, it's not. That's probably just the clock. Any of these chips? Is it on the chip itself? Is it on the main chip itself? So there's a difference between being on board and on chip. I'm now pretty sure it's on chip. That's interesting. That's cool. It's weird that it's not, it doesn't seem to be calibrated right, because according to my thermostat in the room, it's only about 70, it is about 71 degrees in here. So, and then so if I let go, if I put my finger on that extra chip there. Okay, so ooh, don't want to stress that because it's a micro USB, it's not a USB-C. When I put it down, the cable kind of bumped, the cable bumped something, and you can't bump micro USB connectors too much. You can bump USB-C all you want. Those things are secure as a motherfucker. But oh, where was I going within all of this? Okay, so ADC, get out of build. See on board. So Vim, onboard temperature. So there's the conversion from Celsius to Fahrenheit. Conversion factor, we do float ADC read times conversion factor. So if the unit is C, return that. If not C, or if it's F, Or we return -1. In fact, that could be interesting. What if we define it as G or K? How about we do it that way then? In fact, I'm gonna go make this. Oh, hello. Is it? Uh-oh. Is it Control Z A? No. Control Shift Z A? Q? Uh-oh. Hang on. H-top. Minicom. Let's just kill Minicom. There we go. And then we'll leave this open. Minicom ACM1. Hello? Uh-oh. Well, I don't think I like that. Dev. Well, it asked me for my password. Okay, so I didn't put my keyboard into a weird mode. Lock file is stale, overwrite. Oh, hello. Oh, here we go. It is now reading. There we go. So now we have a, let's go into build, C, not console, temperature. Make J4. Awesome. So in theory, it says Kelvin, right? Ah, come on, there we go. So now that I've unplugged it, it says cannot open. Plug it back in so we can program it. And we'll copy onboard temperature UF2, run me. That, so that should program it. There you go, look at that. It says -1 Kelvin, which is not accurate. But the only reason it's not accurate is because the sample program was written in such a way that it only likes Celsius and Fahrenheit. Let's set it back to Celsius. Broke it. Pull it back out. God damn it. There we go. Plug it back in. Make J4. Copy the new over to that. And now the chip is putting out Celsius-based temperatures. Okay. Should look at, is that on board versus on chip is so weird. Is it on board or is it on chip? Is what I want, is what I really want to know. I guess I'm not really going to get anywhere with that. So, let's close some of these tabs. Go back into our code. Let's see if we can make sense. So there, we're init all standard IO. Default LED pin. We set the LED pin to out. Initialize the AD converter, onboard temperature sensor, and select its channel. You should see, but beware that this is a global operation. Oh, that's right. That's right. That's where we were in this SDK. There was the hardware ADC. Here's the example code for the ADC. Okay. Oh, okay. Here we go. RP2040 has an internal ADC with the following features. So that's on chip, because they're mentioning the RP2040, not the Raspberry Pi Pico. Now, What's the difference? For those of you who don't know, where's the picture of it? Okay, we'll use this picture. Everything green you see here, everything inside the green box is the Raspberry Pi Pico. That is the board. This chip right here is the actual RP2040. That is a custom piece of silicon that Raspberry Pi have commissioned and built. It's an ARM Cortex-M0. So even inside of this is a temperature sensor. So that's actually really cool to know that. Where's the documentation again? We've got direct memory apps access. We've got interrupt generation. 5 input mux. Oh, here we go. Initialize the ADC hardware. Can I zoom in? Make it readable for you guys a little bit. Select input. That temperature sensor enabled true. Select input 4. So that's the channel. It is interesting that it's now saying there's 4 channels. Set the ADC clock divisor. Oh, wait. Did it say that it's connected to a specific pin? 5 input mux, 4 inputs available on package pins shared with GPIO 29 through 26. Internal temperature sensor. Okay, so there are 4 ADC channels on the chip. Where is that? I'll move that there. Okay, so we have dark green is an ADC. 0, 1, 2. Analog ground. Ref. So there's only 3 channels, but apparently there should be 4. The documentation is saying there's 4. Let me double check. Okay. Yeah, 5 inputs, 4 inputs that are available on package pins shared with GPIO 26, 27, 28, and 29. Okay, so let's go back to the pad. 26, 27, 28, and where's 29 at? 15, 28. Let's see, 18, 19, 21 to 23, 24, 25. 23, 24, 25, I guess that's down here maybe? But 26, 27, 28, and they don't say 29, I guess. Oh, there's 25. Wondering where that was. I guess VREF is supposed to be the 29. That's kind of an interesting conundrum. Okay, so we look at functions. We have GPIO init, ADC init, ADC read, ADC run, enable or disable free sampling mode. Really? False to disable, true to enable free running conversion mode. ADC select input. Select an ADC input 0 through 3. 26, 27, 28, and 29. 4. Input 4 is the onboard temperature sensor. Oh, okay. Oh, wait. No? Whatever. There's the clock divisor. If non-zero, conversion will be started at intervals rather than back to back. That temperature sensor enabled. Okay. Okay, so that's out of the ADC. Where do we have Hardware I squared C. Let's look at that. See if any slaves are present on the I squared C bus. Print out a table that looks like this. Now what is the... Yeah, well, UART so that we can print... They have a... Do they contribute the CMake list? They do not. Standard IO. Where does... So we have... That could be interesting. I'm going to build... I am going to wire up... Well, should I? My mind's going in like 5 different places at once right now. Do I want to start working with the extra chip, the ADS 1115, knowing already that I'm probably going to replace the ADS 1115 with another with either the MCP 3208 or something else. Important question. Or do I just keep playing with the ADC as if it were a toy? Or maybe do I start learning to mess around in Rust? You know what? Maybe we ought to try messing around in Rust just a little bit. Pi, Pico, Rust. ADC. Rust on the Pi Pico from Slushy. Here we go. Let's see what Alex Wilson has to say. Prepping the program. Example Pi from the RP Hal project. Oh, RP Hal, right? Pico. So you want to program your new Raspberry Silicon microcontroller using Rust. Yeah, see. But Rust, though. Rust would be fun. We want to try out some examples on one of our supported boards. Board support packages. Hal boards. Is there a list? Ah, okay. Wanting to write code. Creating includes RP2040 Hal. Adafruit Itsy Bitsy, KB, MacroPad. Okay, so there's a bunch of Adafruit Trinky? T2040, is that a thing? Oh, no. Pico Lipo, 16-bit? Okay, do they link it to... Aha! How much is that board? 13 pounds, not United States freedoms. Got it. So probably stay away from the Pimeroni stuff. Solder Party? What's Solder Party? Ooh. $264 kilobytes of SRAM. Okay. Or system RAM. Oh, here we go. 8 megabytes of flash. Low dropout. 3.3 volts. All 30 GPIOs broken out. That's good. A NeoPixel. Where's that at? Oh, that's probably on this 21 here. Okay, so if let's get started, actually. You want to write an application, check out our project template. Why not? Let's play with it. Pico examples. Let's get clone. Let's clone this. RP2040 project template. So cargo probe RS. Oh, no. Getting started. We want to try out some examples of one of our supported boards, board support packages. Before trying any of the examples, please ensure you have the latest stable version of Rust installed. So let's do Rust up self-update. You should probably use your system package manager to update Rust up. So sudo Rust up. I kind of don't want to fuck with it too much. Okay, so let's not actually. Rust update stable. Yes. We're installing things and Rust format. Got it. Target add. Downloading component. Oh, it's already done that. Awesome. You may also want to install these helpful tools. Elf to UF2RS. Locked. Doing a lot of compiling. Awesome. ProbeRS. That is a lot of compiling. Actually, flashing over the SWD pins. Oh man, and it is really hurting my frame rate. Oh no. Come on. Hurry it up. It's hurting my frame rate. My viewers. The viewers don't know what they're looking at. Should still be compiling, I think. Let's see. So, project template. Includes all of the knurling. See through the frame rates. Alright, ProbeRS is configured as a default runner. Alternative runners. Not ProbeRS. Embed. What was it I compiled earlier? Oh, whoops. Elf to UF2RS. Okay. Now, running for debug, we do cargo run for release build. Development dependencies, requirements. ARM Cortex, let's see, flip link. Okay, boom, okay. We're through the worst of it. We've compiled the programs, cargo embed, cargo flash, and probe MS. Running, alternative runners, installation. It's also ProbeRS tools, including ProbeRS Run, our recommended default runner. Elf to UF2. Now is that okay? Here we go. Loading a UF2 over USB. We install the UF2. Modify cargo config to change the default runner. Aha. So we then do cargo config. Target is thumb6. Runner should now be ELF2 UF2RS D. Oh. I should have seen that. I could just uncomment that and comment that. Boom. The all ARM wildcard is used by default in template files, but may also be replaced by thumb v6m none ABI, which is exactly what it's already done. Boot your RP2040 into bootloader mode. Use cargo run. Okay, so let's take a look actually at cargo generate. Let's do main RS. So we have info, program start, provide an alias to our BSP so we can switch targets quickly. Core. Okay, so we have external high-speed crystal on the Pico board is 12 megs. That makes sense. And then we want to make sure to unwrap that value so that we know that once the clocks are set up, if it's not set up, the thing panics, which is what we want. It should panic if something goes wrong. So. Alternative runners, I don't care. Feature flags, where is... Not VS Code, source. Okay. On other boards, even if they have an onboard LED. So let's just see if we can compile this. We'll get out of here. Is it Q? Q? How to quit out of minicom. Control A to get the message bar at the bottom. Z, Q. Leave without reset. Yes, please. Jesus. Okay. A Pico. Rust. Oh no. Okay, get out of the Pico examples. Now what's our RP2040 project template? Cargo run, I think? Is that how you deploy? Flip link was not found. Project template, flip link. How do I allows you to detect stack overflows on the first core, which is only okay, sudo. Is it on the Arch repos? Flip link, yes. Okay, so cargo run. Unable to find mounted Pico. Cargo, what can I do? Build? So there's .cargo, cargo generate. Don't see any UF2 files. Oh, build. Build. Memory.x, out.dir. Is it in .cargo? Let me just navigate. So there's cargo generate, source target, debug, build. Ooh. Project template. Oh god. So are these folders? I don't see the edit hell. RP2040 project template out. No? Debug, build. RP Pico? Build script build? No. Okay, installation of dependencies, cargo install flip link. Cargo embed already exists. For running, run release. Okay. So if it's cargo, run. Doing a lot of compiling. Able to find mounted Pico. Dev. Okay, so what if maybe I need to put it back into bootloader mode. Cargo run release. Transferring program to P. Oh, wow. Okay. Wow, that actually worked surprisingly well. Just put it in bootloader mode like I should have done. So if I do dev TTYA, only ACM 0 comes up. So that means, okay. So it's not actually print. I didn't set it to print anything, but I did set it to blink the light. And I don't have a camera pointed at the light, but I can tell you, the light is blinking. And yes, indeed, it is blinking and it's staying on for 500 milliseconds or half a second. It's half a second. And then there's also, so it turns on, it waits half a second, and then it says off somewhere. I don't know where off is, actually. Cargo run release. Running. Run release. You do not specify, it will be, that means print line statements will be printed. If you wish to override this. Okay, so what if I override? So let's go into the cargo config file. Oh, nope. B. So we have linker, flip link. Where is env? DEFMT log is set to debug. Print line, statements will be printed. Trace cargo run. Environment variable so that it applies to every, okay. Alternative runners, loading with Pico tool. Attributing. So we do have definitely, that's definitely running Rust code compiled and deployed to the IO. So the next thing would need to be, is there a ADC? Boards. RPHAL. RPRS. Project template. Pack I2C. Flash algo. Boot 2. There an ADC? No. Pico, Rust, USB, print line. DHT11. Okay, so what does this do? I need to see the output via either serial or even console, but when I try to run, not able to run the process. Code snippet got mangled. Nothing happened. RTIC, USB serial, UF2. Okay, yeah, there's the pin out. Yeah. Now is there RTIC USB serial? So let's see what this actually says. Main RS. Oh, that's just formatting. Wrapper, right. Counter, struct. Where is main? Entry, I think. FN main. Or maybe not. Starting project template for development is an SFC. And the Arctic book. Okay, so what if we clone that? Pico, git clone. Oh, no. Copy that. Git clone. Raspberry Pi Pico. Is there build argo.toml? Runner? There's panic probe, USB device. Does he have instructions on deploying? Installation steps. Ah! I hate it. I hate modern webs these days where it's like, you think you can click on text because it's not built to look like a link, but it actually is a link that goes somewhere. It's infuriating. Self-update, update stable, install probe run, flashing over detect Stack Overflow. Okay. So connect your Pico. Okay, to clean, clear, cargo run release. Okay. So let's unplug this a little bit. Put it back in bootloader mode. Let's say cargo run release. It's doing a lot of compiling. Hamza. Hamza? How you doing? I'm doing alright. I'm feeling pretty good myself. I'm working on deploying some Rust code using nightly blending panics are not supported without standard. So how do you feel? What's on your mind right now? Not compile. Core libraries usually precompile with panic equals unwind. That's good. That's good. So rebuilding your crate with panic equals abort. Not be enough equals finish the problem. So why is it? Make sure you're really. Is this the same? Yeah, this is the same thing. Cargo toml, image, memory X. An essay on ethics and fairness in AI. Really? Connection diagram. So we have Rust up default nightly. Why? Loading with probe 1 or probe run. Why is it like 3 a.m. and you're bored? Well, hopefully I can be a little bit of an entertainment for you. Let's see current. Why is it not? Okay, that's just the HAL itself. Oh, this dude didn't even. Did this guy even? Let's see. Oh, okay. Install a reset button. Oh, okay. Study the Rust examples. How to program the Pico in Rust. Okay. ERP24 pack. He just put everything in here. To compile and upload. So hang on. Run media. Okay, so I am in bootloader mode because I do have the folder. I do have the folder on it. So we are in bootloader mode and it's waiting for a file. Locked, cargo install probe run. Useful. Okay, what if I cargo install probe run? Okay, so it's instead of that, cargo install elf2 uf2 rs. Package is already installed. Really? So probe run and flip link. Shared in local state in Arctic. So why image? So there's the pinout. There's, what is that? Oh, that's the button. So what's build rs? What's that doing? Output directory, linker search path. It's creating a file, memory.x. Byte. Okay, that doesn't seem all that important. Config toml. Okay, so it looks about correct. So why is it cargo run release cargo build? Yeah, so what if I just say cargo build? What does it do then? Cargo build release. Okay. Unwinding panics are not supported without std. Why did it do that? Error unwinding packages. Make a no standard. So if I go into source, no, main, no standard, huh? So why, what's the problem again? Using nightly cargo, use Z build to avoid unwinding. So if I say Z build standard, panic abort. The Z flag is only accepted in the nightly channel of cargo, but this is the stable channel. What's... Okay. Usually pre-compiled with panic equals unwind. Rebuilding your crate with panic equals abort. Okay. Rust, panic, abort. Is that a cargo toml file? Profile release. Okay. So it is a cargo toml thing. Profile release. Debug 2, debug assertions false. I'll just say panic equals abort. Build standard. Z flag is only accepted on the night channel. We're rebuilding the HAL. We have the... Oh, jeez. I'm gonna have to read this manually. Linking with CC failed. Extern functions could not be found. Some native libraries. Why? Ah. If I just read the raw file, we zoom in a little bit. So digital output pin, PAL, pack, crystal frequency, USB device. Okay, so here's our init. Resets. We have a watchdog. We set up the watchdog. USB serial. Not quite understood to me right now, but I can see that there is a serial thing happening. Create a USB device with a fake vid and PID. Ooh, someone's faking. We're faking USB, ladies and gentlemen. Okay, task that blinks the RPi Pico. Oh, man. Yeah, I think I let myself get in a little over my head with the Rust stuff. Maybe I do want to go back to C. Maybe Hanny was right. Maybe Hanny was right. I hate to say it. But maybe I ought to just go back to C, where I know what I'm closer to knowing what I'm doing. But we are about 5 minutes from coming up on 3 hours anyway, so I think it's probably about time for me to start install Python. I'm not doing MicroPython on here. I'm not doing MicroPython. MicroPython's a whole other beast. It is an entire other animal. So I am, for now, I think I'm gonna go ahead and I think I'm closing down. Let's go. Let me see who's live right now. Okay, do I want to raid Enigma, who's doing some video game stuff right now? What's he playing? Bloodborne? Good friend of the stream in Eternal Enigma. Or do I want to do someone who's also doing software? That's the eternal question, isn't it? Let's see who's doing software and development. Who's on in this category? Let's see, handmade. Okay, no, that looks like it's a music thing. No, let's see. A map editor for Fallout 2. That might be interesting. Donut game. Maybe. Classic Doom mod manager. Oh, somebody doing Doom stuff. Okay. There's Doc Sandwich on. Oh, he's French. Not that I have anything against the French, but his title is in French, so sending some English speakers his way, I don't know, will be fully appreciated. Art and Dev Day. RenPy Art and Dev. So someone's making a visual novel, it looks like. There's me. Payments and subscriptions. Game development Q&A. Game development can be messy. That's probably not the worst idea to send you over there. So let's send you guys over to Raid Paradox 927. And I do hope I see you guys soon. Oh boy. Send that to 1. There we go. We're gonna go and see Paradox 927. They're doing some game development stuff. I will see you guys around. I'm gonna keep studying this Raspberry Pi Rust stuff and the C stuff and the ADC. Hopefully I'll be more prepared next stream, or we may go back to just reading the Rust book. Who knows? But you all have a good day.